Hello and welcome. Have you ever faced one of those infuriating errors? You know the kind where your application stumbles on some minor hiccup, like trying to find a log file that's locked, or maybe a network timeout when fetching some crucial data. And instead of simply moving on, the entire application throws a tantrum, shuts down, and leaves you stranded. Annoying, isn't it? Well, today we're going to take a look at how Scala helps us manage these scenarios with something called try, success, and failure. Now, why would you care about this? Well, because it's the difference between gracefully handling an error and having your application come to a screeching halt. It's like having a backup parachute. Something goes wrong, you just deploy it and keep sailing on. Today, I'm going to show you how try success and failure performs practically said error handling capabilities. Let's start by writing a function. I'm going to attempt to divide a number by 0. We all know that's pretty risky. Try in Scala is a construct that lets you execute a block of code that might go wrong. It consists of curly braces where your risky code goes, a pattern matching sequence that matches on success, which consists of result of the about try and a failure consisting of the exception of the above try. Let's just go ahead and import these. Now, when you put a risky bit of code inside try, it gives you a sort of a safety net. If things work out, you get a success. That's when everything is gone according to plan and you get your expected result. And failure if something goes wrong, with the exception containing the information about why things went wrong. Now, you might be wondering, what sort of things do engineers put inside try block in real life applications? Quite a few actually. Let me give you some examples. Imagine you're connecting to a database. Databases are wonderful when they're working, but if your application fails, it can throw all sort of errors. Maybe the server's down or you've typed the credentials in wrong. We've all done it. In production, you'd often put the database connection inside a try block. That way, if there's a problem, you catch the error gracefully and can perhaps try a different solution or log the issue without bringing the entire application to a halt. Another good example is file handling. Suppose you have an application which writes the application logs to a log file. Now, files are tricky things. Sometimes they're missing, sometimes you don't have the right permissions, and sometimes the directory you want to put them in is simply locked. You don't want the entire super important application to crash just because it couldn't write a puny log file. In real life applications, engineers will often put these kind of file operations inside a try block. If the file isn't accessible, you can handle it gracefully, maybe try another way, or notify the user instead of crashing the whole program. And there you have it. These are the type of operations we typically put inside the try block. Now, let's get back to our code here. I'm going to demonstrate this with an example. In this little example, I'm going to divide two numbers. Put this try block inside my function. When we wrap the division operation in try, it checks if the division can proceed smoothly. If it's successful, the program will give us a result wrapped inside success. We're just going to return that back to our function. But if there's something wrong, like trying to divide by 0, we get a failure. In the failure case, we don't panic. We simply write down the exception and return default failover value. That's the typical construction of a function using try. The try block executes a risky function, returns two scenarios, a success or a failure. In the success, it contains the result of the risky code, and in the failure, it contains the exception in case something happens. I'm going to write another function without try, like a noob. Now I'm going to call this function. First, let's try the divide without try. I'm going to use relatively usual numbers, print the answer, and in the next line, I'm going to say the application has moved on to let us know that the application has indeed moved on. Let's do the running. Great, nice and easy. The function works as expected, but what happens if I try to divide by 0? Oof, not what we want. That's not going to give me my salary hike. Let's run the function with try and see what happens. I'm going to divide by 2 just to see how it behaves. Behaves as your normal function. Now, let's divide by 0, shall we? And there we go. Much better. Instead of crashing, we get a polite little error message, the default fallback result, and we can see from this line that the application has indeed moved along happily. So, in summary, try, success, and failure are brilliant tools for handling risky code in Scala. Try helps you protect against failures. Success is what you get when things go well, and failure is what you get when they don't. And by handling these two scenarios separately, we make sure that the application is more reliable, more resilient, and far less likely to alarm your users with unexpected crashes. That's all for now. I hope you found this little foray into error handling both practical and, dare I say, reassuring. Subscribe if you'd like to see more about these sort of topics, and do remember to incorporate this try, success, and failure in your future applications and get that yearly salary hike. And if you can, try not to divide by 0.